back or transporter erector will tilt back just a couple degrees in preparation for the final minutes of countdown. It will still be connected.
Retract has started.
There's that call. The retract has started. That strong back provides power, fluids, and communication for the rocket up until the time of liftoff, when it will tilt back even further away from the rocket. So keep your eyes on that. But Philip, wanted to have you tell us about the path for today's flight. The folks along the southern coast of California might get a treat if they're outside looking up to the sky.
Right. I'm definitely happy for the people out there in Southern California because, we get a million launches out here, but, if they can finally see some, especially at JPL, because it's, they're invested in this launch. So Vandenberg is really convenient for these high inclination launches. So Sentinel-6 Michael Freilich has a 66-degree inclination, which means that it's perfect for the Falcon 9 to launch south-southeast, and it's really going to kind of ride along the coast of Central and South America on its way up to that 1,300-kilometer altitude.
Yeah, very good. We just heard there Tim Dunn coming on the nets and giving his official go. So NASA is go for flight here. The last few minutes here, we're going to hear a number of calls with closing out liquid oxygen or LOX, and then we'll kind of tick down here to the final minutes where we'll hear we're commanded for final pre-launch. We'll have the automated flight termination system will be configured for launch. We'll get a final go from the launch director at around 45 seconds to go on the way to 0 there, right on time for this instantaneous window at 12:17:08 Eastern Time. That's 9:17:08 there on the ground. So Philip, really fast here as we're waiting for the liftoff. Tell us about the rocket here. Awesome. So much coming up here. Post liftoff is certainly active as well. About a minute into flight, we'll hear calls for flight through max Q or maximum aerodynamic pressure, and then we'll about 2.5. Strong back retract has been completed. There you go. You can see a nice separation there between the rocket and that transporter erector. About 2.5 minutes into flight, we're expecting to see a few things happen very rapidly. We're going to see that booster separate after that first stage engine cutoff happens, and then after that separation takes place, the second stage.
Stage 2 LOX load is complete.
There's that stage 2 liquid oxygen load complete, which is great. You kind of see some of the steam coming off the vehicle. That's dealing with cryogenic fluid that's on the order of negative 330 degrees Fahrenheit. It's densified liquid oxygen mixing with the ambient temperature there, which creates that fog, that steam effect. We'll also see a lot more happening post liftoff, so stay with us. And we even have a lot very, very late into the show today. We're roughly an hour and a half of milestones past liftoff of getting into the correct orbit and confirming that we have a good, healthy spacecraft. So please stay with us. There's a ton going on, but we'll let you listen in these last minute and just enjoy the countdown.
Falcon 9 is in startup.
Launch director is go for launch and landing.
You may notice some water beginning to flood the pad here. That's very intentional. That's actually a sound suppression system that occurs to allow the sound of the vibration of the sound to actually be suppressed, and it also helps with some cooling as well.
Falcon 9 is configured for flight.
T-minus 15. 10.
9. 8. 7. 6. 5. 4. 3, 2, 1, 0. And liftoff of Sentinel-6 Michael Freilich, continuing a legacy of ocean observation and international collaboration to benefit all humanity.
M1D propulsion is nominal. M1D propulsion is nominal.
Power and telemetry nominal. vehicle is supersonic. Vehicle is experiencing maximum aerodynamic pressure.
So there we heard that call for max Q. We also heard vehicle is supersonic, meaning it's traveling faster than the speed of sound. A beautiful shot there from the first stage looking down towards Earth and seeing the plume there created by those 9 Merlin 1D engines. Beautiful clear skies there from Vandenberg on the ground, able to track with that rocket as you see it on screen now. Just a reminder coming up here very quickly, we're going to hear booster or first stage engine cutoff.
Stage separation confirmed.
Booster separation is there visible on screen now. Beautiful shot. There's the backflip, as Jesse mentioned, beginning with the Falcon booster.
Stage 1, boost pack burn is started.
And that second engine looks like it has lit. You can start to see the engine bell there turning an
Both
orange.
vehicles are following nominal trajectories. Fairing separation confirmed.
And there goes the fairing. That's exposed. That is Sentinel-6, Michael Freilich there on your screen. That is the satellite that has been exposed now because the fairings have been jettisoned and separated, and you just saw it there tumbling away. Some beautiful shots on the way to orbit.
And stage 1, boost pack burn shut down.
So we're getting reverse angle views of that engine on screen. That's what you're seeing. This is switching between opposite sides of that second
Both
stage.
vehicles continue to follow nominal trajectories.
And that term nominal being used, we've heard that a lot during this call out. That's a very good sign. Nominal just means that everything is going according to plan within the expectation of operation for the vehicle. So we are, there, a great shot from the first stage. You can see the hypersonic grid fins there that are expanded, those honeycomb-shaped structures. As the booster begins to enter the atmosphere, those will be able to help guide and stabilize the booster to make sure that we hit that pinpoint landing like we heard that question asked. How do we ensure pinpoint landing? And those grid fins play a huge part in that. That second stage is in the middle of its first burn. This burn will last approximately 6.5 minutes. And then there will be a long coast phase today. And then we will have a very short, a relatively short second stage, second burn to put us in the correct orbit to follow that path of the Jason series, as we heard earlier. So, Philip, from a trajectory perspective, is this just kind of a moment where do the people working this mission, do they kind of just sit and wait as well here? Because obviously we're not controlling this actively. It's just the vehicle, in theory, just doing what it's programmed to do.
Right. I mean, I will say I didn't personally work this mission, so I'm not sure what my coworker who worked it for the past couple of years is thinking, but it's beautiful to watch this trajectory that we've been planning out for years. We know what the math looks like. We know what the numbers are, but actually seeing these views from the second stage is just amazing.
Yeah, very good. And we'll talk more about kind of your role and what you do as a trajectory analyst. You are, by all accounts, a rocket scientist, which is pretty cool. We will come back and chat more in a bit. Again, we'll revisit you once we get towards that second stage, second burn. But for now, I think we're ready to head back out to check in with Daryl and Jesse to hopefully enjoy
nominal trajectories.
What I would expect to be a beautiful, very noisy nominal landing of that booster. Daryl, how was launch? How did it look out there? All right, we're going to hang off. They're not quite ready yet. I'm sure they're just enjoying it. They probably got up to watch that launch, and they're probably getting positioned again. So I don't blame them.
Me neither. Yeah, they should definitely soak it in.
So that second stage Merlin vacuum engine, MVAC as we like to call it, that produces around 210,000 pounds of thrust once it's on orbit in the vacuum of
Stage
space.
1, entry burn has started.
All right, so call for the entry burn there. I think Daryl and Marina are ready for us. They should be there with Jesse to talk us through the landing. How was launch?
Oh my goodness!
It's incredible.
It was incredible.
That's why we're late. We're all talking at the same time. It's great. Can you tell that we were excited? We were standing there. We saw it. It was so clear we could see the separation as it was going the entire time. Jesse, I mean, isn't that
awe-inspiring?
Mind is blown.
So it's going to be landing right behind us, and we've got a view now of the actual booster coming back. It's got its grid fins out. And that's helpful. It has to use those things.
Yep, it has to help steer it as it's making its way back to land. So it's the steering mechanism.
It's really interesting that it lands right next to the launch pad. We have a little tent over top of us, so we're not going to see that first boost back burn. But we have a clear shot of it coming down onto the pad. The other thing we're waiting for, and we're making sure that we keep track of, is the engine cutoff of stage 2. And we're going to call that out. Here it comes. There it is!
Wow. Oh my goodness.
Coming in at an angle and just straightening out. What do you think, Jesse? That's amazing.
Oh my goodness, I might cry right now.
This is so incredible. Every time I see this, it's just
slowing down so perfectly.
Perfect.
Just hovering. There's the sonic booms we talked about, and touchdown.
Oh my! We heard that.
Oh, that was
And Falcon 9 has landed at LZ4, landing operators proceed into 11.100 on recovery 2.
I'm a little
the
teary-eyed right now.
echo of the power to see it here in person, to feel it.
Oh, and like Jesse said, no matter if you see it or not, you always hear it, right? So that sonic boom is recognizable wherever you are.
Reverberating through the valley here.
I know.
Well, what'd you think, Jesse?
Oh, I have no words. That was incredible. Like, as many launches as I've seen, seeing it in person is a whole different experience.
And the crowd that's with us, you can hear them cheering and everything. They're just totally like, in awe. We're so glad that we could do this and have you join us with this. Jesse Anderson from SpaceX, lead manufacturing engineer. Thanks so much for coming out here. What a moment.
So much for having me. This has been amazing. Thank you.
Absolutely. Thank you. All right. Well, the coast phase is about 45 minutes away. And so we don't expect any activity to report at this time. But if there is, we will let you know. And in the meantime, we'd like to tell you about the science behind the Sentinel-6 Michael Freilich mission. And we're going to get to that in a moment. But, we have a moment here where we're going to sync up and simulcast with our partners from the European Space Agency. And when we do that, that's going to allow both channels, both ESA and NASA, to carry the same broadcast at the same time. Going to talk a lot about science, and we're going to get to that in a moment. But first of all, I want to get your reaction to watching both the launch and the landing.
It's spectacular, Daryl. I mean, it's so beautiful when everything comes, and like Jesse was saying, a well-choreographed ballet. It's the best choreographed ballet in the world, and it did everything that it was supposed to. The launch was beautiful. I'm so glad the winds quieted down when they were supposed to so that we could get that rocket launched, because this is incredible science that we're going to get from Sentinel-6, and I just can't wait.
Well said indeed. Okay, now we are going to turn it over to our friends from ESA. Let's join moderator Louise Houghton from the European Space Agency.
Sentinel-6 really would like to thank NASA and our friends in the US, also NOAA, for this contribution they have made. Incredible. They have been an excellent partner. They have been very reliable, and they really have delivered their part on time and in very significant terms. The launcher we have just seen, but also very important instruments like the microradiometer and several other components. And this is a model cooperation I would really like with Thomas and his team in the US. Discuss further cooperation opportunities, because this is just so wonderful what we have done with Sentinel-6 Michael Freilich, and there is much more to come. I have quite a few ideas. I don't want to go into depth right here, but I think this is so successful that I would like to expand that.
Well, thank you so much, Josef. I think you're saying there that international partnerships are so important for these space missions moving forward. And we've, of course, been able to monitor the oceans from space for nearly 30 years now. And before we continue this conversation, I want to take a look at a video which will show our achievements to date.
Right.
Sorry, this is a little...
You're coming back to me, or?
Yeah, we are.
What would you like to ask me so I can gather my thoughts?
It's okay.
Nadia?
What difference is Sentinel-6 making to revolutionizing oceanography?
You still have 10
minutes. You've got time. We've got plenty of time.
Please,
You'll be out after the video. You'll have like six minutes.
I don't hear the video. I don't hear the video.
She's missing.
She doesn't have a feed.